Hey guys, this is a question from a K12 test. It says a ladder leans against the wall. It's based 15 feet from it. When the ladder is pulled 5 feet away from the wall, the upper end slides down 9 feet. How long is the ladder? Okay, so one of the most important, we start off by remembering that the ladder, the length of the ladder does not change. Okay, this is something that we take for granted. It's obvious, but sometimes we take it for granted and we can't see the problem clearly if we don't specify this. So okay, so if we look into our problem, we see that we've got a wall here and a floor here, and then we've got our ladder chilling something like this. This is the first position, and then they say that the ladder is pulled out 5 feet further, and then it's that position. So we can start by saying that this length is L. Oh, just hold on. We can start by saying this length is L and so is this length because it's the same ladder. So both of these are L. So they start off by saying that this length is 15 feet, and they say this is a further 5 foot that they pulled the ladder out. Now they don't give us the vertical height, but what they do give us is that they say this change over here from that point to that point is 9 foot. This is what we have. This is the information that we have given in the sentence. Okay, so if we look at this problem, we can see that the wall, the ladder, and the floor, they form what is known as a right triangle. And immediately what we can do is that if we have a right triangle, um, if we have a right triangle like this, with side A, B, and H, Pythagoras says that A squared plus B squared equals to H squared. Okay, so this side squared plus this side squared plus this side squared gives us this side squared, or the side squared. So you get what I'm saying, is that the side squareds gives us the length of the ladder squared. Okay, so we will start at that point. Now we have another thing that we need to do. We need to identify the initial length, and we need to try and specify what it is in terms of an unknown. So what I'm going to do is this length right here, I'm going to call it x, and then we need to specify this length as well. So what we're going to do is that we are going to specify this length in terms of x and 9. This is the information that we already have, and we don't want to add any more information. So if we specify this in terms of x, then we have this length right here equals to x minus 9. If you can see, here's the whole length is x, that section is 9, so this has to be x minus 9. Okay, so that means that we can set up two equations from the get-go for these two triangles. What does that look like? Okay, so if we're focusing on the blue triangle, so this is the first case, which is, sorry, the blue ladder, the ladder in the blue position, we can see that it says x squared plus 15 squared equals to L squared. That length down here, this length over here, the x side over there, and this 15 over there. And if we look at those, we can see that we've got the Pythagoras triangle, or right angle triangle, where we can apply Pythagoras. Okay, so that's the first case. The second case, we can say that now the length is x minus 9. Remember the x minus the 9, so that length gives us x minus 9, and we have to square this whole thing, and then the other length is the 15 and the additional 5 feet that they slid out, so it gives us 20 feet. So that's 20 squared equals to L squared. Remember, the ladder's length does not change. Okay, so what I'm going to do is I'm going to add a page, and we're going to rewrite these equations. X squared plus 15 squared, x squared plus 15 squared equals to L squared, and then we have x minus 9 squared plus 20 squared equals to L squared. Okay, so I'm going to I'm going to work on the second equation. I want to expand it a bit. I don't like what this part looks like. So I'm going to change it. So what we're going to do is we're going to say x squared minus 18x plus 81 plus this is 400 equals to L squared. Okay, so what we have now is that we can simplify this a little bit and we get something like this: x squared minus 18x plus 481 equals to L squared. We can now name these two equations. This is equation 1 and this is equation 2. Okay, so now we can simultaneously solve it. But what we also see is that both of these equations they're equal to the same thing. So what we can do is we can equate the two equations to each other. So we have x squared minus 18x plus 481, and that equals to x squared plus 15 squared, sorry, my bad. So let's simplify, or let's expand this even further, just for completeness sake. 481 equals to x squared plus 15 squared is 225. Okay, so we can see that there's x squared on both sides, so we can cancel that out. That is not an issue anymore. And what we want to do is that we want to subtract 481 on both sides. So what we have is minus 18x plus 481 minus 481 equals to 225 minus 481. And this might seem weird, this whole operation right here, but that is generally what we do when we move, when we, in inverted commas, move numbers over to the other side. We subtract it on the one side, we subtract it on the other side. Okay, so what we left with is minus 18x equals to minus 256. Yes. So we see that there's a negative on both sides. So what we're going to do is we're going to divide by -1, and we'll have 18x equals to 256, and we'll find that x equals to 256 over 18. I'm not going to simplify that right now, just leave it as is. Okay, so what we want to do now is that we want to substitute x into one of our initial equations so that we can find L, because that's actually what we are here to do. So what we're going to do is the simplest equation. If we look at these equations, which equation do you think it will be simpler to substitute the x into? This one looks a bit messy because you have to substitute into x squared as well as x, whereas over here it's just x squared. So I prefer to use equation 1. Equation 2 can also be used, but I prefer to use equation 1 because it's much simpler than equation 2. Okay, so then we have 256 over 18, that is squared. Let me just rewrite these quickly. Let's start here and say x squared plus 15 squared equals to L squared, and x we know equals to 256 over 18. So now we're substituting for x into there, so it's 256 over 18 squared plus 15 squared. We said 15 squared is 225, so let's put it in there just for simplicity's sake, and that equals to L squared. Okay, so now I've got this fraction, but fortunately it's just a number. We punch it into the calculator and it gets sorted. But now this L is not what we're not looking for L squared. We actually want L. So what we can do is we can say L equals to the square root of 256 over 18 squared plus 225. And when we put that into the calculator, let's do that quickly. Just give me a second. When you put this into the calculator, we end up with an answer something like 10.22 feet. That is how long our ladder is, and we've done it by solving a system of equations simultaneously. So in closing, one of the most important things that we need to focus on is trying to go from here, from this point to this point. This is the most important skill, being able to take the word problem and putting it into drawing a picture and trying to put it into a symbolic form in which we, or a mathematical model. In this case, we put it into the Pythagoras model, and we used the Pythagoras model to solve these equations. So it's very important to try and get the word sum into something mathematical. But yeah, thank you very much for watching. I do appreciate your time. Cheers.